Howdy guys, welcome back to Cruiserman's Inventions. This is a hub motor and also a video about how they're rewired, the wiring diagram between a hub motor of a push bike and a washing machine hub motor and how they're wired, okay, and what the difference is. Now looking at this picture, this is how they're wired. Now you know on your controller how you have the three phases coming in. These are the colors stand for your phases all the way around. This is a 18 pole motor, and so as you can see, it's like pole 1 would go here, pole 2 and pole 3 would go here. But as you can see, look at the direction. In a washing machine motor, these colors are all close together. I'll go to the next one, guys, so that you can see this a little bit closer. I have a little video clip coming up, guys, of how this is wired. Yeah. So you can see the hall sensors in here, here, and here, and where they're positioned. But the reason why it comes up here, gets wound around this way, and then comes up here and gets wound around backwards the other way, is to create a north and then a south pole on the one phase. And that's why it's like that. And as you can see, they've got it going one way, then back the other way, and then back this way. So that'll be north, south, north. But they've got that on the one phase line. See, and they don't have that on the washing machine motors. Okay, so I'll just go to the next one, guys. So this winding on this particular hub motor, which is a Bafang one, was 7 turns at 10 strands of 0.5 millimeter wire. That's 10 strands joined together at 7 turns per pole. Okay, you see that? Okay, and that made 48-volt motor. See, now the interesting thing about those is these motors were wound to be generators, 48-volt generators, and as a 48-volt motor. And it's the same with the washing machine motors. Now this is the starting winding of a star configuration. That's the first winding here. I start off with the earth one, and then I'll go to the next one, and the next one's just easier for me to wind it this way. This is the end, this is the beginning. So as you can see, it jumps to, and then you wind it there, jumps to, wind it there, and it does that whole configuration all the way around. And then you put the other one in, which you go over here. So I started backwards. This is like earth in a sense. Then the next one will be negative, and the next one will be positive. But it's alternating current in here, so it's not actually like that. But if you actually look on these washing machines, they're actually labeled with letters on them explaining that those are the colors. So as you'll see, this is why I add colors in, and it makes it easier to wind. Now this is it actually jumped straight forward and actually all wound, guys. And you can see the colors I've used. The first one red, the second one blue, and the third one had nothing, right? So that's that all wound in a star configuration. Now at the end, where is the end? Okay, at the end up here, that's right, I tied off all the 3 wires from the 3 poles at the end here, soldered them together, and my input wires are here and here. They're a bit hard to see, so let's go to another. Here we go. Soldered that on the end. You see those 3 poking up, and then I put these connectors on there and soldered them on, crimped them and soldered them on, and then after that I insulated taped the colors on there so I knew which way. You see, because your controller actually has colors on the phase wires themselves, so this just helps you out, right? Color match. So I gave it a little bit of clear gloss all around here because some of the shellac was actually coming off this wire a little bit. So everywhere it did, I just added some insulation tape and then clear coated it afterwards just to protect it furthermore. This is the shaft that I was bolting it onto, guys, and as you can see, I made it around the original center and upsize the bolts. What else? This is it bolted on now. And I tell you, in the star configuration, what we were trying to do was get the motor to run smoothly and get the controller to register a load. Now this is a washing machine. The way it's wired stock standard, it's a 1.14C, and that's the star configuration. So if you're wondering how my motor was rewired, it was like I said in my last one, 17 to 18 turns per pole, 1.5mm wire in this configuration. And let me just say, guys, if you saw that last motor and how fast that spun, I did actually create a load. See, this is one stock standard. I did actually create a load. See, I took all of that wire out of there and I put in my own. That's like 190 turns per pole, and I only put about 18 turns per pole. But this is only 1.8mm wire. I used 1.5, so it's way bigger than that. It's just about twice the size. So let's go to the next one. This is a hub motor of a push bike. This is Bafang motor. So this is the top lifted off. This is the planetary gear system inside to help it get up hills and all the rest of it. This is the neodymium magnet system that's inside it. Pretty close together. This is the wiring system that I just showed you the wiring diagram for. And that's me. Okay, guys, so let's go and have a look at this motor. Let's go and have a look at this motor. So in here we have the, oh shit, I just broke my pants. Oh my god. Oh. Okay, so that's the one that we saw in the last video. And if I can remember right for you, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 poles linked in, another 12 and another 12. And man, let me tell you, this thing is fast, but I also ground down these a little bit to give it some airspace so that nothing hit, because you don't want these hitting on the magnets on that rotor. And this here, guys, is the brand new one, fully in a star configuration, trying to create that load. And I took all of that wire there off this one here. Oh my god, my pants are just popping galore. All the stitching's gone. Okay, so let's tune this on, guys. 1000-watt controller, 48 volts, but I've ramped it right up to 72 volts. That's 6 of these 9 amp hour 12 volt batteries linked in series, taking a negative off the end and a positive off this end. The meter says 75.3, and you can see the colors, and this is just the way I've got it hooked in, right? So no sensors or nothing, and the 3-speed wires here are detached, so it's stuck in middle gear. If you join the black and that one together, that'll be maybe low or high, and if you take the black and join that to the pink or whatever, that'll be low or high. I don't know which way it's around, but open like that is middle gear. So let's try it out on middle gear. Let's ramp this thing back, guys. This is very interesting. Alright, let's go just a little bit. There we go. A little bit more. Here we go. I tested this out just before, guys. That is super strong. You can't stop this. You can't stop the motor. Look at that. It's powerful. But that's how fast it goes. I wish I had a meter to show you how fast this was sort of spinning. But you know that the other one in the other video, this spun twice as fast. But it may not have the low down power that I need for this drift trike. I know this will. Look at that. Perfect. It's not going, it's not doing none of that. Look at that. From start all the way. You want to see some volts drops. Here we go. There we go. Leaving it on. Leaving it on. I can smell some wiring. Oh, oh no, must be that shellac. Oh, very economical. It's not dropping very much. Look, very economical. Very cool. Yeah, alright. I'm holding it on, guys, full throttle. This thing hasn't dropped a beat. Look. Alright. Let's check the temperature of this thing. Cold. 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 Batteries. Cold. Wow. So, okay. So this is very interesting. Now that I've rewired all of this, I think it's actually successful that to go ahead and put this on the drift trike. Of course, I'm going to have to take off all of this stuff, which was part of the other test on the system, which is a window wiper motor, which I had turning on this big sprocket, going back to here, turning this as a generator. It worked out pretty good. I had this running off a DC controller, 24 volts, so I could alter the speed of how fast I was turning that. Wow, guys, let's ramp this up again. Look, it's 775. Woo! You know, that's safe enough for kids. If this was on that, it probably wouldn't go too fast for the kids, but it would have a lot of power and probably get you a lot of distance, I reckon. So anyways, guys, hope you enjoyed that, and I might fiddle around with these gears at some stage too, see if I can get it to go faster. So awesome stuff, guys. I hope you enjoyed that. That was the difference between the wiring diagram of one of these washing machine motors and a hub motor. So if you see this on a drift trike of mine, it's actually running as a washing machine motor, not a hub motor. Cool, guys. Just rewired, of course. Cool, guys. Big thank you to everybody that watches Cruiserman's Inventions. Don't forget to like, subscribe, and this wiring expedition has taken me 2-3 days. It's been a mission. Whew. Thanks for watching, guys. Cruiserman out. Whew.